Physical Science, Module 5D, we'll be talking about glaciers and icebergs. Our most important source of fresh water in Earth's hydrosphere is the glacier or iceberg. This consists of a little more than 2% of the water in our hydrosphere. At this point, what I want you to do is pause the video and read Experiment 5.2 about ice and salt in your text. Go ahead and download the lab sheet 5.2 from the email sent to you. Fill in the Materials and Procedures section of the lab sheet. Then restart the video and watch the experiment. So what happened in Experiment 5.2? When salt is placed in the ice cube, the piece of ice cube under the salt melts faster than the rest of the ice cube. It was difficult to see in the video, but in the video a chunk of the side of the ice cube fell off. Many times you'll see a hole form in the center. The reason this happens is that salt water freezes at lower temperatures than pure water freezes. When salt touched the ice cube, ions in the salt attracted water molecules to them. Some water molecules in the ice moved away from the other molecules in the ice, forming a saltwater solution. The solution then stayed liquid because the ice cube wasn't cold enough to keep salt water frozen. This is the same technique used to melt snow and ice on roads and sidewalks. What happened to the second part of the experiment? When the students tasted the ice in step 8 of the experiment, they were surprised. The expectation was that the water would be fresh water, but it was actually salt water. We need to think back to Module 3 and what we learned about solids, liquids, and gases. The major difference between the three states of water is the motion of the molecules or atoms. Remember that solids are only allowed to vibrate back and forth. Liquid can move about with quite a bit of freedom. For liquid to freeze, enough energy must be removed to slow the motion of all the molecules. In the case of our experiment, this means that both the water molecules and the dissolved salt must be slowed down at the same time. Though salt and water are slowed down at the same time, they do not freeze as salt water. The salt water freezes separately, becoming a highly concentrated mixture called brine. So, a cube of frozen salt water contains solid water surrounding little pockets of concentrated salt water. When the ice cube melts, the salt remixes with fresh water. This process makes salt water again, not fresh water. I want you to pause the video and complete the lab sheet for experiment 5.2. Return to the video after you have finished. So what have we learned? We just observed a process that shows that icebergs are composed of fresh water. There's a misconception that icebergs are frozen ocean water. In certain polar regions, the water in the ocean does freeze to form sea ice, but sea ice is not composed of fresh water. Sea ice is actually a mixture of solid water and brine. Some of the brine can be forced back into the sea. However, the amount of salt in sea's ice is not as high as it is in seawater. The salinity of sea ice ranges from 1 to 10 grams of salt per kilogram of ice. So if icebergs then are not salt water, what are they? Well, icebergs come from great glaciers. Every iceberg starts as a glacier. Every winter, new snow falls, adding to the existing snow. Old snow underneath the new snow gets packed down into what's called firn. Firn is a dense, icy pack of old snow. Over time, the whole mass of ice and snow gets so heavy, it starts to slowly slide down the mountain and move across land. Take a look at the figure on page 118 of your text. It's a great picture of this process. The speed that glaciers move is very slow, less than 1 meter or 3 feet per day. There are, however, records of glaciers moving more quickly. In 1999, the Columbia Glacier in Alaska was clocked moving at 35 meters or 115 feet per day. As glaciers move, they sculpt the earth that they travel over. This motion can carve valleys and move large rocks. The glacier will have soil and dirt in it. Remember back to when we talked about how salt gets into the ocean? This is part of the process. As a glacier moves down the mountain, it will reach an altitude where the snow and ice begin to melt faster than new snow can replenish it. The glacier starts to melt, feeding many freshwater sources in the hydrosphere. Glaciers in the polar regions, though, never reach the melt point. Polar glaciers flow into the sea, forming huge sheets of ice. Almost the entire Antarctic continent is covered by ice that comes from glaciers. Antarctica has an area of more than 5 million square miles. Glaciers have pushed some of this ice out to sea, forming large sheets of ice. The large sheets of ice are called ice shelves. One of these shelves is called the Ross Ice Shelf. It's the size of the state of Texas. As glaciers advance into the ocean, the ice weakens at some points, and large chunks of ice break off of the glacier, floating away in the water. Take a look at this picture. You can see this chunk coming off of the glacier, and you can see another one getting ready to do so. This process is called calving. Calving makes icebergs. Most of an iceberg is underwater, about 90% of it, so we only see 10% on the top. This is why they're very dangerous. Ships can run into icebergs easily. An iceberg is a portion of a glacier that is broken off and floats in the ocean. Ice shelves are the ends of glaciers that float in the ocean. A glacier is the result of heavy snowfall in the mountains that doesn't melt away in the summer. The largest sources of fresh water on the planet, icebergs and glaciers, are the result of precipitation, so water and snowfall. Without that snow, we would not have fresh water. You should have the information on this slide in your notes. And go on to do the on your own problem in your book, and we'll talk at you at the next video.